Hello everyone, this is Professor He. Welcome back. The topic of this subtask is about the first law of thermodynamics. You may know energy in your daily life. Do you know what is the energy? Although everybody has a feeling of what energy is, it is difficult to give a precise definition for it. Energy can be viewed as the ability to cause changes. Now, let's have a look at the history and development of the word energy. The term energy was coined in 1807 by Thomas Young, and its use in thermodynamics was proposed in 1852 by Lord Kelvin. The term internal energy and its symbol U first appeared in the works of Rudolf Clausius and Werner Rönne in the second half of the 19th century, and it eventually replaced the alternative terms inner work, internal work, and intrinsic energy commonly used at the time. By the 1840s, the basic concepts required for the principle of conservation of energy had been almost completed. The impossibility of the perpetual motion machine is another important clue that leads to the establishment of the principle of conservation of energy. A lot of great people, including Leonardo da Vinci, have paid amount of wisdom and labor in order to create an ideal perpetual motion machine which can continuously and effectively work without consuming any fuel or power. Since the 13th century, the failures of all kinds of perpetual motion machines revealed to think from the opposite side. Whether there is a universal law in nature which restricts people to create an effective motive force without paying any price. Philosopher Hegel put forward an idea of connection and transformation between various natural phenomena. Among 1840s, there was a general idea among the European scientific communities to observe natural phenomena from a view of connection. More than 10 scientists who were engaged in different disciplines in Western Europe had independently discovered the principle of energy conservation. Major scientists who independently discovered the principle of conservation of energy include Mayer, Helmholtz, Joule, Carnot, Grove, etc. The law of conservation of energy links all kinds of natural phenomena with quantitative laws and points out that mechanical motion, thermal motion, electromagnetic motion, and chemical motion are all special forms of the same motion under different conditions. They can transform each other without any loss in quantity under certain conditions. Friedrich Engels pointed out in 1885 that the principle of conservation of energy emphasized the imperfection of conservation and changed it to the law of energy conversion and conservation, revealing the essence of this law. There are various forms of energy in nature: thermal energy, mechanical energy, electromagnetic energy, chemical energy, light energy, atomic energy, etc. Different forms of energy can either be transferred or can be transformed. During the process of transfer and transformation, although the form of energy can be changed, the total amount remains the same. Law of conservation and transformation of energy. General principle of nature. Now, let's introduce the statement of the first law of thermodynamics. The first law of thermodynamics, also known as the conservation of energy principle, provides a sound basis for studying the relationships among the various forms of energy and energy interactions. Based on experimental observations, the first law of thermodynamics states that energy can be neither created nor destroyed during a process. It can only change forms. Therefore, every bit of energy should be accounted for during a process. Also, the first law of thermodynamics states the perpetual motion machine of the first kind is impossible to be made. We all learn that a rock at some elevation possesses some potential energy, and part of this potential energy is converted to kinetic energy as the rock force. Experimental data show that the decrease in potential energy exactly equals the increase in kinetic energy when the air resistance is negligible, thus confirming the conservation of energy principle for mechanical energy. Careful measurements during experiments indicate the following. For all adiabatic processes between two specified states of a closed system, the net work done is the same regardless of the nature of the closed system and the details of the process. Considering that there are an infinite number of ways to perform work interactions under adiabatic conditions, this statement appears to be very powerful, with the potential for far-reaching implications. This statement, which is largely based on the experiments of Joule in the first half of the 19th century, cannot be drawn from any other known physical principle and is recognized as the fundamental principle. This principle is called the first law of thermodynamics, or just the first law. Thermodynamics tells us that a process cannot take place unless it satisfies both the first and the second laws of thermodynamics. Any device that violates either law is called a perpetual motion machine, and despite numerous attempts, no perpetual motion machine is known to have worked. But this has not stopped inventors from trying to create new ones. A device that violates the second law of thermodynamics is called a perpetual motion machine of the second kind. The proposers of perpetual motion machines generally have innovative minds, but they usually lack formal engineering training, which is very unfortunate. No one is immune from being deceived by an innovative perpetual motion machine. As the saying goes, however, if something sounds too good to be true, it probably is. Okay, that's all for this task. Thank you very much and see you next time.